Let me go through a kind of a very quick presentation which I prepared is regarding a kind of digital construction technology I would like to bring. All the kind of structures we've been talking last 2 days, what we want to do is how this is digitally built first. I think that is what is a kind of a topic of interest and the kind of a little learnings what we have done all through last 25 years. I thought of maybe giving a few glimpses of it. We are basically a kind of a German-based consulting company. We have offices in India. Chennai and Delhi are the kind of a main nodal offices. If you look at a kind of a 25 years of a legacy, we have operated in 20 different countries with 400 qualified people in 6 global countries which we have opened the office. This is what is a kind of a mode of operations we do, a kind of a hybrid working. India is always a kind of a major market where we look into kind of a resources at a kind of a top end of a site where we have made a kind of a disruptive technologies, especially in terms of a time and technology, working on a collaborated, integrated projects, which brings a kind of a lot of cost saving. We also like to bring a kind of a the experience what we have gained all through kind of a global to kind of a local. If you look at a kind of an engineering, yes, we have operated all sectors, say it's a kind of all kinds of buildings, bridges, tunnels, which are our favorite. Highways, interchanges is always we do day in, day out, and always we operate and getting onto a kind of a sustainability, hydro, and all other sectors. We work for all the design consultants, international design consultants, and design partners, especially for the contractors, to make this constructible engineering solutions. That is what I talk is building information modeling. What is building information modeling is basically a kind of a functional representation and a physical properties representation of an assets, which in a digital form. And these are the kind of a design applications and design software that we call as a kind of a BIM authoring tools we apply. Majority is from Autodesk, Trimble, Allplan. We operate quite extensively. I would like to give a kind of a very quick case studies, the success stories we've been doing with BIM. Yes, I hope these are the kind of a few basic things where all these models, what we do is a parametric objects. We create a kind of a families of these, primarily run a kind of a interfacing between these and produce a kind of a clash reports. We do a kind of a time analysis, attached to that 4D simulation, 5D analysis, and a lot of innovation, automation happening by writing program scripts, and we produce documentation right from LOD 100, 200. All the materials you talk about, what we've spoken, all these materials and structures, we can produce a parametric objects, steel, concrete, M&D, or rebar, precast technology, pre-stressed, all these elements, steel, concrete. These we have produced parametric, and we have produced all the kind of documentations what are needed for the constructions. What we, in short, I try to explain, we are at a kind of more or less a kind of a level 0 or level 1 where we are using a kind of a CAD-based solutions. But however, we have to claim to level 2 where a kind of a building information modeling can be applied and a communication between the stakeholders can be made much more intelligent to produce the documentations much more better. So this is what we have learned through whatever the kind of architectural, structural disciplines and MEP services we can bring into a kind of a one modeling environment. We have a kind of a plenty of applications thanks to technology which has given a kind of a leverage to civil engineering fraternity to produce the documentations, coordinate them, interface and produce the documentation what is needed for the construction. We have gone to an extent where all the shop drawings are the construction documents which are produced up to a level of machine fed. All these documentations, what I say is the output files or the machine-fed files, NC files or whatever the kind of numeric computed files needed could be produced using the documentation. Yeah, somebody says that, okay, if I have the auditorium of 200 seat capacity of such kind of a documentation coming from the design consultant, is it something which is possible? These are the kind of a plan sections, elevations, which are done in 2D. If I have to produce and take it to the site, is it something which is possible? No, it is. We have to produce the kind of a BIM models where we have the kind of a civil, structural, architectural, MEP models are produced to extent of LOD 400, the kind of a shop level of a detail and extract the documents what is needed. I think this is what we've been doing with. Let us say like we are sitting in this auditorium, similar kind of an auditoriums, yeah? If at all, a lot of a kind of a, what you see is a kind of a more on an external phase, but however, there are a lot of internal services which are running under that. If all have to produce the documentation, these are all produced in kind of a Revit platform, and all these things are coordinated well, and we have taken the documentations to the construction site, see that erection installations happen hassle-free. This is what a kind of a technology I thought of might be bringing in, where all the models are produced first, digitally built first before getting onto the construction site. I think there are plenty of challenges we are discussing onto the construction site, but these things can be resolved in a kind of a design office. Look at the kind of an MEP services which are running through in all different spatial directions. Unless we visualize, create a kind of a parametric objects where the technology is available, we would be in a position to make a clear documentation, hassle-free construction, cost savings. Of course, we do a lot of a kind of a scripting programs are involved to make the kind of a documentations very successful, and we resolve all the clashes before getting onto the site. Otherwise, a lot of time wasting happens on site, how the installation clashes can be resolved. Yeah, this is one example on the building side where we, and at last, we produce a kind of a very clear, clash-free models and the documentations. Once the documents are produced, your plans, sections, elevations, concrete, architectural, structural, mechanical, electrical, your schedules, bar-minute schedules, everything can be produced and sent on to the site. I think this is one of the kind of a recent success story what we have done for the Hong Kong project. This is one of the projects which we have done is in 2010, 2015, where 35 square kilometers of city development happened with a barren line. We've been given a kind of just a barren line where we have to produce all the digital assets, right from highways, highway structures, all the civil infrastructure utilities. You talk about a kind of a stormwater, foul sewer, irrigation, electrical, all the placeholders digitally were built and delivered to the client. I think this is what we are doing it kind of a day in, day out. And this is one of the projects which we have recently produced for a US project. One particular thing we have seamlessly taken is in this project is we have created the kind of a model in a Trimble business center, and these models were linked to a kind of a rotor grader. So all the setting points, survey points can be set out automatically. So what we are trying to do is the kind of a white hat we are converting into a blue hat. The informations which are seamlessly getting integrated in a digital way. So this is what is becoming a kind of the workflows. This is one other example which if at all you have to know all the soil subsurface data, we can import geotechnical information reports or investigation reports into a kind of a borehole data. I can create a complete subsurface data. You can identify how much amount of a volume of soil needs to be discarded, or the kind of which has a chemical attacks or need to be environmentally to be discarded. We can identify, we can give a kind of a volumetric measurements as per the actuals. This is one of the projects which we are recently doing for the Canadian project, 18 kilometers of a railway. This we have done for the dam project, around 180,000 meter cube of filling was produced in a kind of a borehole data where the contractor is in a position to code the project very well. So we are quite active participant in producing the kind of a BOQs as per the international standards and give the documents as per that. This is one of the some bridges we have gained that kind of experience last 25 years where producing the kind of a documentations what are needed for the construction. There is always a kind of a little gap between the design consultant and the contractor. These gaps are we fill with a kind of engineering services. You talk about a kind of the composite sections, what we have done. This is one of the recent project, almost all close to $20 billion US. We got involved in this one. All the documentation it has a precast a kind of a technology utilized all the piers, the capitals, and the deck slabs were the precast. So these were modeled and with a level of a shop detail. Shop detail means every nut, bolt, rebar are produced with a precision and delivered to the client. So you talk about a kind of a visualizations. I think we have done quite enormously and quite active in that. Look at a kind of a rebars. This capital has got 4 layers of a reinforcement which is running in a kind of a very elliptical shape. It is something which cannot be produced on site. This need to be, we have done a kind of a high level integrate model. The technologies are available. Trimble gives a kind of an option. Allplan gives an option. This technology we have adopted, created the kind of a high level of details which are quite useful for the construction sites. So primarily, all the kind of clashes are getting resolved digitally first before going onto the site. So what I'm talking is the hassle-free construction. We have also done in India. L&T was also asking one of the project in New Ganga. We have done a similar exercise where the composite box girders, where we have especially the kind of the PT cables which are running through longitudinally and transverse direction. It has got a kind of a lot of interfacing need to be done. We have produced a complete documentation and bar bending schedules fully cleaned and gave it, which is a kind of a success to that. We have also recently done for a few other jobs. SP Singla is one recently we have done, because they came up with a kind of a precast girders which are manufactured at a precast yard are getting wasted because they are not fitting on site. So there's a huge national waste. So that is what I'm telling. The kind of the designs, once it is done, we have to also detail it properly. The technology is available to do a kind of a complete documentation what is needed for the construction. Says something, such kind of documents are coming from the design consultants. No one at the construction site can understand this. We may have to convert these things into kind of a precise models. Also, I was talking about a kind of a time essence. Time is also shrinking for the construction projects where the technology need to be embedded with the engineering. So that's what we are making a kind of a programs. Now look at a kind of where a kind of a cleat need to be connected to the kind of the top of girder. This is one of the kind of a cyclist 2 kilometers project which is running under the kind of a precast girders. We have done a kind of a very precise detailing, and these are all going for procurement directly, where the kind of a Fresnet is producing the kind of that tension rods, what exactly need to be produced. So I think one particular thing, we are running a kind of a programs. Designs which are coming out may not be sufficient to get into the kind of a construction site so precisely with a kind of a time frame. We need to run programs. Thanks to technology, again, it is going for a great extent to make the kind of the documentations very precise. One particular last thing I thought of maybe producing is recently we have done this project. This has got a kind of a pre-camber and it has got a double curvature. I don't think so in India it is attempted. MTHL was doing it in Mumbai Trans Harbour. L&T was doing it, but at last they have made this kind of a straight obligatory spans. But this is something which is a kind of a double curvature and a pre-camber. It was something which, what we have done, the design models and the shop models to be produced in a span of 3 months. So we didn't had a choice to produce these kind of a documents using a kind of a technology. Grasshopper Rhinos has got a kind of a technology. We have run these programs, and these are all directly linked to a kind of a shop models. And what I'm trying to say is these models are now untouched, zero untouched models. It's all fully scripted, parametric. What you change in the program, it gets changes in the models itself. So once the models are produced, we can have all the kind of documentations which are needed for the kind of a fabricator, including the NC files, so that can straight away get into the kind of a fabrication. I think this is one kind of a success story. You look at the kind of the scripting we have done so intricately, yeah? And once the scripting is done, these scripts are directly linked to the kind of a model, yeah? Models are not touched by the humans now. These are all directly linked with the kind of a programs. That is what I'm telling is technology is getting immersed into kind of engineering side in order to make a kind of a time and a money saving, which is bringing success to the construction projects. I think a lot to go. There are a lot of cutting edge technologies. We are building it across. And this can help all the kind of civil engineering fraternity.